Okay, so we started with application layer, then transport layer, network layer, and we're down to the link layer. Okay. So some of the things that you do in the link layer, things like error detection, how do you share channel. There's a whole new set of addressing in link layer different from IP addressing. And then we spend some time about local area networks and related topics. So basically, let's quickly get to what really is the function of the link layer with respect to other layers, especially IP, which is the network layer. So we saw that IP is responsible for directing traffic on the internet. So if there is a packet that comes in here to this router, okay, it came from somewhere, this router gets this packet, it looks at the table and decides that this particular packet needs to go in this direction, okay, and it does not go in this direction. So that's pretty much all the network layer does, directing traffic, whether it goes to the router to the left, router to the right, or router straight ahead. But what next? The network layer has no idea how to get the actual data across. Okay, so it just looks at the addresses, looks at the seam, and decides the direction. The network layer does not even know if this is a wired link or a wireless link or what kind of link it is. So essentially, the job of the link layer is to transfer this datagram from point to point. So in this case, to get this datagram from this router to this router, whether it's a wired link, wireless link, Ethernet, whatever it is. So that's what link layer does. It's a point-to-point protocol. So in terms of terminology, we call the packet at link layer a frame. Okay. So the packet at the network layer was called a datagram, just so that there is different terminology, so we can distinguish between the two. Although I'm sure I misspeak and say the other thing. What's the packet at transport layer? Anybody remember? What are the pieces in transport layer? No. Segment. Although I may have used the term packet just as often as segment, but just to distinguish, it's a segment at transport layer, datagram at network layer, and then a frame at link layer as we go down the stack. Okay, so far so good. We'll skip the analogy. It's something we've seen before. So one thing to note here is for the first time, at the link layer, as a packet goes from one endpoint to another, from your machine, say, to a web server, it goes through a whole different series of protocols. So the network layer, IP is a global protocol. The whole world uses basically the same scheme. TCP, UDP are global protocols. Everybody uses the same thing. But link layer is very close to physical layer. The protocol is going to be very different if you are on a wired link versus a wireless link, because it matters now. If you're on a wide area network link, which is connecting from 100 miles from here or connecting you through a satellite, you're going to have different protocols. So link layer is really a family of protocols that takes you from one point to point, and the specifics depend on the type of link that you're using. So again, the services a link layer offers are going to vary a lot depending on what link we're talking about. But some services are basic. One is that you have the IP datagram, and typically IP is carrying inside it a TCP or a UDP segment. and link layer adds another layer. So if this is the link layer, then it's going to frame, that's what's framing. It carries the IP datagram as baggage inside it, and it will have its own header. So every link layer protocol has to do that, one way or the other, frame the data, put a new header, and move on. The addresses that a link layer uses are different from IP addresses. They're called MAC addresses, and let's discuss a little bit later why you need a different set of addresses and why IP is not enough. Okay. So reliable delivery. Okay. So we saw this reliable delivery at transport layer. TCP has reliable delivery. There is no such thing at network layer, and the question is, do you need reliable delivery at link layer? So it turns out the answer depends on what kind of link that you're talking about. If your link is a fiber link and some kinds of wired links, they are extremely reliable links by themselves. Fiber is the fiber's claim to fame is that it rarely corrupts data, rarely drops things, and so on. So in those situations, you do not do reliable transport. If you lose, you lose. Okay. However, a wireless link, as you all know, it's a very high error rate link. The wireless can lose a lot of data because of lots of reasons, because of physical things coming in the way, or because of other machinery operating in the vicinity. So in that case, the link layer will actually have something which tries to recover, has reliable delivery. If something gets lost, tries to send it again. Okay, so anybody wants to take a crack at this question? Why do we even worry about reliable delivery at link layer when ultimately it's going to go up to probably to TCP, which itself has reliable delivery? We saw how TCP does things. If something gets lost, you figure it out, it's retransmitted, and so on. So why do I even need to bother, even if it's a wireless link? Because TCP is going to figure it out. And if it's UDP, well, we expect it to lose things. Penalty. Could be. Why would it cost more? Just more sophisticated, because of so the answer is the protocol is more sophisticated at higher layers. That may be true, and it is true that the penalty is likely to be much higher at TCP versus at individual links. But why would that be? Sophistication is that's a part of a protocol. Well, if you think about it, you have these two endpoints, and you have a bunch of routers, maybe 10, 15, things like that. If something gets dropped here, then or corrupted, the whole corrupted thing is going to keep going. Okay, and you're trying to send a stream of data, First of all, it will take a long time before you even figure out that something is wrong, right? Because TCP will keep going, and somewhere the sender is keeping track of ACKs and things like that. A long time later, you'll realize, oh, something is missing. Okay, So in the meantime, you've done nothing for recovery. And secondly, once you do recover, then the whole packet has to be sent again the entire way. Okay? Well, if you could recover here that something was wrong, you can quickly send another packet just on this link and not bother the whole network from end to end. So end-to-end recovery